Welcome to the Power Players by Origis, featuring solar and energy storage leaders and their critical thinking to deliver the clean energy promise. My name is Cynthia Khatib. I welcome you to this episode hosted by Michael Eyman, Managing Director of Origis Services.
All right. Well, welcome to another episode of Power Players. Today we are with Amanda Bybee. Amanda has worked in the solar industry since 2003. Over the course of her career, she's helped to launch several cooperatives, all employee-owned, Namaste Solar as a employee-owned cooperative, then purchasing cooperative, Amicus Solar Financial Cooperative. I didn't know about this one, by the way. That's pretty cool. Clean Energy Credit Union, and shared services cooperative, Amicus O&M Cooperative. Recently, Amanda has contributed time and energy to several other projects that are closer to her heart, such as the Women's Speakers Bureau with RISE. And that's an industry coalition on diversity, equity, and inclusion that's also called Renewables Forward, and an informational website on how to recycle solar equipment called www.solarrecycle.org. So, Amanda, welcome to Power Players.
Thanks, Mike. Happy to be here.
Happy to have you. Listen, today we are going to talk about mature sites, right? And what is that? How do you deal with a mature site? We spend a lot of time talking about, financing sites and how to structure contracts and how to worry about your costs. But what do you do at that 10, 15, 20, 25, 30 year mark when you're looking at sites needing to turn over equipment on the sites, needing to sort of manage changes in those sites over time, as well as also, there's changes in law and things that occur. But first and foremost, I think, what we really want to talk about as a starting point is we really want to talk about, like, how do you deal with, looking at sites and planning for sites, closing them down over the years. Not just let's start kind of in the middle of the site where you're dealing with maybe changing out inverters, redoing the electrical architecture as those warranties roll off, or you're looking at repowering because you have an old PPA and you're ready to you get more energy out of that PPA and optimize it as an owner. And then also, then sort of move into, okay, now how do you return the land and, back to its original, if you're in a lease and you're required to do that, and how do you sort of demobilize these sites and how do you plan for that financially? So that was a lot. I threw at you all.
That's all we want to cover in the first question.
That's all you want. Go. No, it's I know that's a lot, and I apologize. So let's start. Why don't we start at the end and work our way back?
Sure.
From your perspective, and you've been on the development side of it, you're on the O&M side of it, you've been on the operations and the financing side of it all, and now you're getting it with the solarrecycle.org. You're sort of, going after the end of this thing. So let's talk about the end first and work our way back. Just like the development of any good strategy, start with where you're trying to get to and then figure out how to get there. So
I feel like Stephen Covey has us on that one. Begin with the end in mind, right?
Yeah, exactly. So thinking with that end in mind, what kind of end of life issues should owners be thinking about? And what should they be doing, throughout the mature period of that site to sort of be ready for it? How should they look at it?
Yeah. Well, first off, I'm just excited to talk about these considerations and the full life cycle of our product and our technology, because I don't think that the industry has always done a great job of really thinking that all the way through. We spend, like you said, so much time on the front end.
Yeah.
But what's interesting to me is that starting at the end also requires starting at the beginning. And it really drives home this notion for me that circularity is a critical part of our paradigm shift. We have to get used to thinking about these things beginning to end, which brings us back to the beginning. So when you think about at the end of a system's life, we have used all the life that we can possibly squeeze out of these modules. We've been through several PPAs. We've repowered it. We've really truly gotten everything we can get out of this this particular site. It's time now to return it all to the land. You got to think about it. I think about it in terms of a materials checklist. What are we going to take off of this site and what are we going to do with each of these materials? So obviously you're taking down your modules. You're taking down your racking. Racking generally is metals, right? So you've got modules, you've got metals. Maybe you had some wood products on the site, like poles or fences or posts, or you've got some wood. Maybe you've got a lot of wire coming off. Again, metals. Metals are the easiest to contend with. We've got a very known waste stream and recycling stream for those.
Yeah, there's a secondary market for this grade of steel or that type of copper, and you can have people that are happy to come get it because there's
They
a
can
market.
reuse it.
Yeah, there's known stuff for it. Yeah.
You've got electronics, inverters, tracking components that fall into the electronics category. You've got concrete. You've got batteries. You've got, so you have this list of materials that you're going to need to contend with. And then you have land considerations. Do you need to reseed? How disruptive is it to go through the decommissioning, deinstallation process? What do we need to do to help that land be returned to a usable format? And like you said, some of those materials have really ready, well-established secondary markets. Metals are the easiest, and in any type of a recycling scenario, when you're thinking about how can I take this object, break it down to its component parts, and reuse them in some form or fashion, you have to think about purity, right? Because when you contaminate a container full of metals, you're going to render the final composite weaker than the original pieces. So you have to think about how you're handling that from a purity perspective. Are you sorting aluminum and steel and copper into different dumpsters? How are you doing that? But part of this is just the exercise of like imagining in your mind a crew of installers going out to a site and physically taking stuff down. How are they handling it so that it's easy to then send through the streams that we need to send it to? Which of those have existing solutions, which don't? And I think that racking, wire, wood, maybe concrete even, like you can find concrete crushers that can break it down and recycle it into a new form of concrete or other products. Some of the harder ones that are unique to solar are the modules. The inverters, you could argue, are pretty much like electronics. And so I'm hopeful that we'll be able to utilize existing, e-waste streams for handling electronics. And then batteries is going to be the other one that we have to contend with. How do we return those to put them through an environmentally responsible end of life solution?
So let's talk about a couple of different pieces of that. So, I mean, to me, it's relatively straightforward. You sort of reverse the construction process, and you go in and you have people demobilize and go through and disconnect all the electricals. Disconnect it from the grid, and then make sure that it's safe. Then at that point, and then go through and remove all the DC and pull off all the panels and sort of put those away to one side, the panels to one side, because now you've got the site's dead. You're not going to electrocute anyone. And now you can sort of operate out there as you need to. You can pull all the metal and the wiring out, and you can put everything, copper goes there and steel goes there and aluminum goes there and all that stuff, and break it all up. And then the metals to me are relatively straightforward, right? There's any number of recyclers in any local area across the country that you can reach out to that's happy to take it off your hands, for a fee or for free or for some reason.
Maybe they'll even pay you.
They might even pay you for it if you prep it sufficiently, right? And copper in particular is one that has a high value, right? But I think you hit on three areas that are of significant concern from my experience and perspective, which is the panels, the complex electronics, and the batteries. And I don't think we have great answers on those. So talk to me first about, and in fact, we went through recently with some panels where we've been trying to recycle those. And the question is, who's paying for that? And the owner didn't have it in their budget. They weren't expecting to. And yet here we are, right? It's irresponsible just to throw them in a landfill.
Yeah.
So talk to me about what you see as the best in class. What's out there? What do owners do?
So this question and this lack of awareness and this lack of familiarity with the resources is what led myself and several friends in the industry who are doing this as volunteers to start solarrecycle.org. Those of us who are involved in the project, we care a lot about the environmental integrity of our industry and making sure that we aren't just landfilling those difficult materials. When you look at, we've got over 100 gigawatts of solar installed in the US today. We're forecasting that we're going to add another 300 gigawatts in the next 10 years. We're talking about a significant volume of materials. I'm not even sure the landfills could absorb that well, aside from the environmental ethos that I think we really are trying to reinforce with our industry as a whole. So that was our motivation for starting the website, and just also finding that everybody was out there doing the same research over and over again. So we were like, well, gosh, let's just centralize that and make it easy to find, easy to connect people with the recycling vendors who are taking these products. So that's the whole point of the website, is to just create a resource that serves our industry and makes it easy to find actionable information. So our hope is that people will help us expand that. And as new players come into the marketplace, we meet them, we learn about them, we add them on. So, also embedded in all of this is a need for recycling solutions that are geographically well distributed, because if you have to ship large volumes of material across the whole country to a singular site where they're recycling it, that's going to cost a lot of money. So everything is very, very cost sensitive, in particular because so many systems don't have this baked into their long-term budgets. So I hope that your audience is chock full of financiers and developers in position to make sure that they have realistic decommissioning plans and budgets built around this. As imperfect as they will inevitably be, because who can predict what costs will be 30 years from now, having something is certainly a far better starting place than having nothing. So that's really, really important. And what we're seeing is that today's recycling marketplace has a handful of players. They approach recycling in different fashions. Like there's not a singular answer to what is recycling. There's not a singular federal standard around what is recycling. There's not a singular standard around how to classify solar waste. Right now, we're still in that really fun state-by-state patchwork of policies approach, which means that you have to know exactly what the rules are for every state that you're operating in, how they regard this waste. The waste classifications depend on toxicity testing. There's not a standard for how to do toxicity testing. So we're really, really in the early days of figuring out how to handle this problem. The thinking around that is that we have time, because the vast majority of that 100 gigawatts has been installed in just the last 5 or 6 years, really. Yeah. So assuming that these modules really do have a 25, 30-year lifetime, we hopefully have a little bit of time to figure that out. I think, though, we also see some trends in manufacturing processes that make us wonder if we really have as much time as we thought. And so that's a part of my urgency in advocating for these topics and making sure that we're talking about them today. What if we don't have 25 years to figure this out? And what if we need to know the answer in 5 or 10? That means we need to be working on this really actively right now.
Yeah, and I'll say, the panel issue that I just talked about, that's a midlife issue. That's not an end of life issue. That's just taking off broken panels, either due to weather or mowing or whatever. Mm-hmm. Issues with how they were installed, whatever the case it is. If you have broken panels, you have to go deal with those, right?
Yes.
And so that's happening today. You only have some markets like Hawaii and areas in California where you've got end of life, and those are relatively small numbers because those projects were small 20 years ago, 15 years ago, right? They're 100 kilowatts to 5 megawatts,
Right. We're not talking the large volumes.
No, we're not talking
that we will see in the future.
1 million panels, right?
Yeah.
But it's coming. But what you are seeing is the big sites today, their needs for midlife recycling are actually greater than the end of life on those older projects because the total megawatts are larger, right? From that perspective. And so we don't have 20 or 30 years to resolve this.
No. So I'd say the really truly best in class on what we're doing with those midlife, broken modules today. Certainly, I just want to say anytime we take modules off a site for a different reason, if they still have life in them, there is a very active and hungry secondary market there. Because as you and I both know, when you have failures on a site and you go to look for some of those legacy replacement modules, they're hard to find. So anytime a module has life left in it, Lord help us, don't throw that in anywhere. Make sure you sell that to somebody else who can use it to repair a system. But today, the best in class is to have a recycling vendor who will take the module and strip it down to its component pieces. It's pretty easy to remove the frames, and then you have a nice clean aluminum metal we know what to do with.
Sure.
The sandwich that's left, the glass to backsheet sandwich.
And the J boxes, those things can come off relatively easily, right? I mean, there's some damage.
Relatively easily. That's an interesting sort of side note about how various recyclers will ask you to prepare your mods. Removing J boxes, depending on the module itself, can be really hard to do without creating damage. And so if you're trying to hack that J box off, it's well adhered, right? Because it's supposed to be there for 25 years.
Yeah.
And then you break the glass, and then they won't accept the broken glass. You end up creating more of a waste stream. So there's some challenges around J boxes.
Yeah, we've run into that one. Yeah.
Yeah. But then you have the sandwich is the hard part, because by weight, the glass itself is the largest component out of that. But trying to separate the rest of the backsheet and all of that, which is adhered pretty securely to that glass, again, because we're seeking for a longevity of 25 plus years in the sun, in the elements. It's not very easy to separate that cleanly enough to have clean, reusable glass. So there are various companies and technologies like, super machines that can slice those off, or use, super sharp razors or lasers or various technologies to slice that. And then even if the glass has some remnants of material on it, they can take tempered glass and turn that into other products, right? I know some companies will take that and turn it into like road beads that they use to paint stripes on the road that need to have a certain reflective quality. Or, there's other things that we can do with that. Then you have the cells, the backsheet, the wiring, some of that is lead. So that's, you gotta look at that. Some groups will take that remaining sort of leftover stuff. Some will shred it, some will bake it until it turns into a powder. Some use chemical extraction processes to try to extract the heavy metals and the precious metals out of that. A funny trend an ironic twist in the way that manufacturing has taken place is that old mods had a fair amount of silver in them. Yeah. And silver is the most single valuable component out of the module itself in terms of recycling value. The more we've tried to decrease the price of modules, the less silver they've used. So it's the older modules are more valuable to recycle because you can get a return on that silver. The newer modules, which both cost money to recycle, but you get a little bit more from the old ones that had more silver. The new ones just don't. Yeah. Which is good because it's helped contribute to the decline in module prices, which we need to scale. But it's also made it that much harder to have a return on the recycling value of those products.
What about CDTE modules? Gas deposition.
The largest maker of the CAD/TEL modules has a recycling program because it is acknowledged that there are some toxic materials within those that they have to have a responsible answer for. However, that's also where that preparation piece comes in, right? Removing those J boxes, especially if it's a glass on glass module, you damage that glass and then they don't accept the broken glass. It creates a problematic loop. So I think there's still work to be done. It's certainly laudable that they came to market with a intention and plan for recycling. That's a great start. We may need to continue refining that and helping encourage acceptance of modules that have J boxes or that have broken glass associated with them, because the CAD/TEL is what we want to keep out of the landfills from any kind of concern about leaching into groundwaters or what have you.
So given that we do want to keep the CDTE, the cadmium telluride, I think I said that correctly, gas deposition panels, We do want to keep those out of the landfill. They are particularly concerning. And it is good that First Solar has a program, but just calling them out for a moment because they're the primary producer here in the United States. Excuse me. You know, it's good that they have a recycling program, but they both create a J-box weld that's really, really good, but also require you to remove it without damaging it in order to get it into that program.
Mm-hmm.
So the two design criteria are like at odds.
Yeah. So if you'll humor me for a second, I want to tell a little story because I really think that this is where circularity becomes such an important concept. My family, have you ever heard of a YouTuber named Mark Rober?
I'm not much of a YouTuber, I have to admit.
I'm not either. My kids like to watch it though. And they found
movie
this.
previews is about as far as I go, but
Yeah, that's a good one. So Mark Rober is a former engineer, and he has a YouTube channel where he walks you through all of his build ideas. And he creates really fabulous like explosions and things, but he walks you through the engineering process. And he offers a class, and we signed up for that class as a present for the kids. And so we're going through this class as a family right now, and he really is breaking down the scientific method. And one of the things that I wish and hope to see more of in the industry is that when we sit down to design a solar module or an inverter or anything, that we add to the list of essential requirements for our product the ability to deconstruct it reasonably.
Mhm.
And there's a tension between building a product that's built to last in the elements for 25 or 30 years with one that's easy to take apart. Those two things are kind of at odds, right? But when you build with the end in mind, when you manufacture with the end in mind, and these are not new concepts, right? I read Bill McDonough's Cradle to Cradle when I was in college, and he's been out there advocating for stuff like this for a really long time. But we have to build our products to be returned to the product stream. And this is going to become more and more important as we start to run short of those precious metals that are baked into our electronics, our modules, our everythings. If we can find a way to grab them, pull them out, and reuse them in the next generation of modules and get them back into the product cycle, that's going to save us a whole lot of mining, a whole lot of hardship as these materials become more scarce. There's actually some really great work taking place at Arizona State University. Dr. Meng Tao has been leading this charge for years, but they're working on a way to deconstruct a module, take the silicon cells, clean them, redope them, and redeploy them in a new module.
yeah.
I read an article just recently. They got a big grant. They're working on scaling this up because right now it's just at that sort of early stage proof of concept in the lab. Getting it to commercialized at scale applications is going to take a lot of work, but we need to do that. But we also need the engagement of the manufacturers to help us with that. Those awesome welds of that J-box are proving to be challenging for us to deal with. So is there another solution to that we can approach by adding a criteria to their design process to say it's got to be able to be taken apart at the end of its life? And making sure that doesn't get bumped into the non-essential list. That's an essential requirement that we need to not lose in the engineering process for these components. And it's not just modules, right? The same would be true for inverters, and the same is true for all electronics for that matter, that we need to be able to extract those precious metals out of our computer boards and everything else so that doesn't get landfilled, so that we can reuse it and we don't have to mine it fresh every time.
So I think, as in most things, I think the thing to point out is why the owners and the financial side of the business should care about this. Because at the end of the day, when they're stroking these checks, and deciding which suppliers they're going to use, they're the ones that have the financial agency to make those choices of this one versus that one, right? And for sure, manufacturers need to step up their game in this area. But the question they're going to ask is, okay, I'm competing in the marketplace on a commodity price basis. How do I provide a product that's able to be demobilized like that and programs for demobilization that work with the owners, when at the end of the day, they're just going to make a decision at the beginning on who got the lowest price thing and that's who's going to win. I'll never win business, so it won't matter that I put those things in place. And it's a valid question.
Yeah.
So I think there has to be, one, there's got to be regulatory infrastructure that requires you to have some things in order to level set the sort of the playing field and the expectation. And then the financiers need to make hard decisions about, like, look, I have this big expense for demob out in the future. I'm only going to buy from a panel manufacturer that produces a product that I can easily demob and that they have a program for that makes sense financially. I'm going to lock that price in as a part of my contract on the front end, right?
Yeah.
Something
Well,
along those lines. And those are the things that we should be thinking about. And that push should be coming from the owners, because where this cost is going to hit is there at the end of the day.
exactly. You nailed it on the head, Mike. And I think that this is a part of training the financiers and developers to think about this stuff. And I think that there's a perception, which I'm sure is not true across the board, but there is certainly a perception that the absolute consideration of first cost as the only consideration, because we got, in order to make it pencil, we have to get our costs as low as possible on the front end, without consideration for demob, without consideration for failure rates, without consideration for, the aspects of these components that make them last. And so those of us on the O&M side are screaming across the chasm, hey, listen, we have something you need to know.
Hello.
We're here.
Yeah.
And so I feel like this is a part of it that I really ultimately chalk up to our industry still being so young and immature. Where some of us who've been around it for a long time, 19 years feels like a long time to me, but where we started was so tiny. And to where we are today, which is we're moving rapidly towards being a truly mature industry. And I think this is where we have a lot of lessons to learn from other industries that have already been through this cycle and who've seen more of their whole product life cycles. And there's a lot of transferable knowledge that we can and should gain from others. And you look at, there's lots and lots of products in the world that have that regulatory infrastructure that forces you to think about it up front. When you buy a can of paint, there's a fee on your receipt for recycling that in the future. Mattresses, tires, like there's a lot of products that we think about that. When you drill a new natural gas well today, you have to escrow money for its ultimate decommissioning. That wasn't put in place because there were unfortunately a lot of wells that weren't capped responsibly and that caused environmental problems later on. So the regulation helped.
Yeah, I would argue, frankly, that the way the oil and gas industry as a whole deals with those costs is by just leaving them in the field until people forget about the holes being there. I've seen a lot of holes in the ground that were not properly dealt with.
Oh, for sure.
And so I think, to some degree, our industry starting in the modern era versus in the late 1800s, there's not a legacy, or mid 1800s, there's not a legacy of a lack of sort of thought around this, right? I don't know that we can really even learn that much from the more mature industries, because they didn't have these requirements, and even when they have had them, they haven't had any teeth.
Well, I guess what I'm saying is that we can learn from those industries who've seen a full life cycle more so than we have. Because you mentioned we've got a few early markets that maybe we're starting to reach end of life, but the volume of that is still smaller today than just incidental damage on a large utility scale site. So, I think there's some things that we can learn, but it's also about teaching the financiers and developers and the people who are really upstream of where you and I come into play. To factor that stuff in at the beginning in the decision making about your procurement, about your design, about your even the manufacturers, like your product design, knowing that these things are going to have to be dealt with later. There's no way you get out of dealing with decommissioning and end of life issues, right? It's going to come, just like end of life will come for all of us.
Well, and I would say that because the industry is maturing, it's not enough that individual companies say this is how we're going to deal with our product, because there's no guarantee that company is going to be around.
Or those individuals will still be working there. Yeah. No, and I think it's an interesting question and it's one that I am excited to delve into in the coming years, because our industry is also so incredibly cost sensitive that if we were to go to the developers and financiers and say, hey, you need to add 5 cents a watt for your decommissioning, they'd be like, are you bleepity bleeping crazy, you
Yeah.
know. And I think 5 cents a watt is probably an underestimation of what it actually costs at the end of the day. I'm just making up numbers here, but we know that projects that are developed today are sensitive to fractions of a cent per watt. So if you were to say you need to add all of this on for decom, it would be a pretty uphill battle. And so we're going to have to decide as an industry what regulation we're going to voluntarily adopt and accept, or we're going to be forced as an industry to accept regulation that someone else is going to impose on us.
Mm-hmm.
And so I would far rather see us engage on this proactively and say, okay, adopting new costs is challenging and difficult, and we don't like it, but we know we have to, because the solar industry was so heavily founded on this idea of environmental responsibility, right? We can't just turn a blind eye to the waste streams that we're creating, because that would be hypocritical and out of integrity. So we're going to have to deal with this, and doing so voluntarily and helping craft those regulations in a way that we can realistically abide by is a far better outcome to me than being forced to accept something that somebody else comes up with. I haven't seen us engage on that yet, but I think it's coming.
So I think there's a couple of challenges with it. Before I talk about the challenges, I do want to point out, if we do further episodes of this to dig into this subject and other ones, I want you to wear a different hat from the wall for each one. There's a lot of interesting options back there, and I feel a little cheated for today. I'm not going to lie to you, Amanda. I do feel a little cheated. I'm sure the people watching do too. But listen, there's, most of these things are looked at on an NPV basis. So when you're looking at the financial modeling of this, even a large expense that's 30 years out at even a modest discount rate has such a small impact on the project today, but you've got to set up an accrual to deal with it, right? So you can either look at it as an expense out in 30 years and bring it all the way back, and then it's so small it's not worth considering, or you can add an accrual that, as a baseline on an annualized basis that gets you to some number out in the future, and then you bring that accrual back on an annual basis along with all the other costs in those years. I tend to think of that second approach as being the one that's most accurate to the risk that you're actually sort of trying to model from a financial perspective.
Mm-hmm.
That said, though,
I've seen some plans that even bake in like periodic reevaluations of that formula, so that you're not just set it and forget it for 30 years, but every 5 years, it's the asset manager's responsibility to take a closer look at what is currently available. Is our formula feeling like it's on track to create a reasonable fund?
And we do that today in the industry to deal with like repower, like bringing in different inverters and updating the site and things like that within its lifetime. But we don't add to that accrual that end of life. And I think capturing it all in that accrual and understanding there's going to be these points along the mature life cycle where you're going to be making investments, and then there's a big demob or reinvestment that's going to happen at the end that's going to happen. but the industry as a whole hasn't really gotten their heads around that.
No,
And the owner, because they're not contemplating that in the costs, they push on the developers, and the developers and the EPCs push on the manufacturers, right? So you need the financial side of it to sort of understand it and then just push upstream. And that's the way that's going to happen, assuming it does happen. Or you can just continue in the industry in an unregulated fashion, and you can have a big winter storm in Texas and nobody can have power because they didn't regulate the traditional industry the way they should have.
For example,
just a random
hypothetical
situation that'll clearly never happen.
Definitely.
So we don't want to be that, and that's a given. So, well, look, we talk about the secondary markets. What about the electronics? Obviously you can take that apart and you can pull steel and you can pull components out and you can kind of do that separately. And I've done some of that in the past where we've put them in a warehouse and we've like done a pick and pull on them until we got them down to shells, and then we sold the metal off, and we kind of did it like that. Do you have any other thoughts on how to do that? That's I'm just an East Texas boy, so I fall back on old methods sometimes.
Certainly. No, I think that I don't love the term, but cannibalizing old boxes for those components is actually a really important strategy. Yeah. And it fits very much into that reduce, reuse, recycle mentality, right? I don't advocate we reduce solar. We need as much solar as we can humanly install. So that one that actually doesn't apply. But reusing all of that as much as we can is great. The more we reduce the requirement for brand new componentry, especially on legacy sites and legacy components that you can't replace, that's the only way to get it. So that's what you're doing is great. I would say keep doing that. So I've also been working on the solar recycle side to try to find existing streams, existing services, existing exchanges where you can recycle electronics. And so like we're exploring options with a partner that's got a site where if you have a bunch of e-waste, you go onto the site, you look for vendors, the vendors will give you proposals, and then you pick the ones you want. And it's done very easily. It's just on a website and it's pretty straightforward and simple. Because I think that's the other key to this is the easier we make it and the least expensive we can make it to do the right thing and recycle this stuff responsibly, the more people are likely to do it. So that's what I'm looking for is like ease of use, ease of user experience, and ease of accessing those resources to make it the simplest choice to make. Of course I'm going to do that. That's so easy. Where's my easy button for recycling all of our componentry? Because to your whole point about like inverter recycling is going to be a bin life issue as well, right? Inverter warranties are not as long as module warranties. So we're certainly going to see a wave of electronics recycling needs in the next 10 years that predate, hopefully, the big wave of module recycling needs.
You know, I agree with everything you said. With one exception that I'll disagree. I'll disagree on is there is a big reduced piece, right? So one of the ways that we sort of meet all of our goals and meet all our needs is that we also focus on efficiency with our use of power as a whole, better building materials to lower our costs and everything else. Otherwise, the growth of the human race on this planet will outstrip our ability to keep up with those power requirements. And
Yeah.
silly uses of power, need to be really reconsidered. And I'll give you a great and maybe not obvious example. Bitcoin mining as an
I was
example.
just going to say, we're on the same
Look,
page.
I'm not a big, I'll admit on the front end, I'm not a big, cryptocurrency guy. I think blockchain has a ton of promise as a technology, but like sort of, making up something that we're going to use as an exchange, I might as well go grab a bunch of shells off the beach. But, creating a false economy by generating random numbers, which set, the minimum amount of something that can go out, into circulation in order to set the rarity of it so that the economics play out, which is what Bitcoin has done, so that now people spend millions and millions of dollars and use gigawatts or terawatts of power and generate heat simply to get computers to guess numbers all day long is crazy.
Yeah.
It's
Well,
absolutely crazy. That is the wrong thing to
no,
be doing with our
I'm
resources.
100% with you on that. And when I say reduce, like I don't want to reduce, I'm talking about I don't want to reduce the use of renewable energy because I think that renewable energy is it, right? But I completely agree with you. And this is another example of looking at blockchain or cryptocurrency. Like they're often closely associated, but I do think blockchain in and of itself has some really interesting properties to it and aspects to it. However, this exponential increase in data usage I don't see any way around it based on my understanding of what it fundamentally is as a repetition
Yeah.
of all this data. Yes, it prevents fraud and it creates this secondary problem of the power consumption. So I think that this is another example of us as human beings solving one problem by creating another
Creating another, yeah.
and needing to have a more holistic view that when we sit down and we define the problem statement and the requirements of that solution, we can't overlook that environmental impact, that energy impact, all these secondary needs. Because I mean, just as a whole, we've become so digitized as a society, right? Data centers take a lot of land, they take a lot of power. And it's to their credit that a lot of the big tech companies are also huge drivers and adopters of renewable energy. But what if we didn't have to create that problem to begin with? Is there another solution that doesn't result in the secondary issue? And I think that this is something that we seem to have to relearn generation after generation as we continue coming up with new things.
Yeah, there's irresponsibility, in how we look at these things. I mean, you could have just as easily have said, look, we're just going to create a random number generator, and all you have to do is push this button, and every time, and eventually when it gets your number, you get one. And then everybody would be buying chicken farms with chickens doing nothing but pecking at buttons, and we'd be stuck trying to figure out what to do with all this chicken poop. Look, the humans are so good at creating problems from solutions, right? So we got to think through it all. I mean, come on.
Yeah.
You mentioned concrete earlier. I mean, I can use concrete like inherently on sites. We dig out areas just thinking about it, and I haven't honestly thought about it before you mentioned it. Honestly, I haven't. Concrete is eminently recyclable, right? You can crush it up and you can use it to create other construction materials. You can also backfill into the areas that the low-lying areas that we have used for water collection, and fill those back in order to reset the land. I mean, there's a number of things you can do, and the amount of concrete on a solar facility is not, the amount of impermeable cover produced by a solar facility is not that great as a percentage of the land. It's really not.
No.
But do you have any other thoughts relative to those kinds of materials that are out there?
I mention it because it came up in a conversation the other day, and I hadn't thought about that either. And so but I do think that the more we talk about this, the more we become sophisticated with our decommissioning plans, the less we overlook. And while concrete may not, in the old days when we did ground-mounted systems, we used a shit ton of concrete, if you'll forgive the technical term. And so, not
a metric. That's a metric measurement. The shit.
Yeah. Right. We're not as familiar with that in the United
Use
States.
that here in the United States as much. Yeah.
Right. So digging that up, extracting the pipe from it, like, you're going to bash it up. You're going to do. It is a consideration. And I think today, utility scale sites, you're just driving piles, right? There's a lot less concrete involved, and that's good and helpful. But, wood is another one. So when you're building a site, you may have some poles, you may have some posts, you may have some fencing. That's wood, right? But the other source of wood that's really problematic is pallets.
Mm-hmm.
And I don't even have my head fully around this, but today, a lot of pallets that are being utilized are made from really, really poor quality wood.
Yes.
You can't reuse them. They're like one or two uses and they're done.
The end of the line, yeah.
But you can't burn them because they contain so many adhesives and like toxic chemical solvents that you can't burn them responsibly. You can't recycle them into anything else because they're pieces of crap, basically. And so, like, what do you do with this giant stack of crappy wooden pallets?
Well, being an East Texas boy, we build deer blinds with them.
But there's only so many deer blinds we can
broader answer to the problem. Look, pallets get reutilized until they break, right? Until the wood cracks or whatever.
Otherwise, the wood is good enough to bear reuse, but when it's not, and it's like single time use.
Yeah.
So I think, this is just another example. I really think that what we're speaking to is broader even than the solar industry, right? We're certainly not the only group to use pallets, but like this whole question of our waste stream and thinking so short term about, oh, it's cheap to build it this way using this cheap stuff. But then we create this whole waste stream problem. This is something that we need to be taking a look at really in a globalized sense. You and I have a narrower lens and view and circle of influence where we could potentially make an impact. I don't know that we're going to change, the whole global thing, unless the solar industry takes a leadership role in that and says, you know what, we're moving very intentionally to these types of voluntary regulatory adoptions where we're going to recycle our stuff responsibly. We're going to invest in circular thinking at the design phase of the product themselves. We're going to insist on reusable pallets because there are companies coming out with options for this. They all have secondary challenges. It's not as simple as saying, let's take that, a composite plastic material and make our pallets and we'll use them for 10 years. Yeah, well, they're really, really expensive up front. So, there's always this trade-off and this whole series of problem solving that you have to go through as you're trying to solve one problem and not creating two or three others. But this type of thinking has to happen. I don't see it as an option that we ignore this stuff for too much longer, because we're going to run out of precious stuff, because we're going to have this volume of waste to contend with, and because out of every challenge like this, there is opportunity. Somebody's going to make a lot of money on these solutions when they crack the nut. And I will celebrate those companies when they do.
It's an interesting problem. I think, we need to spend more time talking about this one. We need to talk a little bit about, what things we can do to dual use these sites. And I have my view on these, and you and I think diverge a little bit based on our different experience with different options. But I think that one's going to have to wait for another day. I will say there have been some really interesting efforts over the years. I know SunPower had some programs when I was there, really trying to build like reusable containers. And so that we're not creating a bunch of landfill. Those were really great efforts. They didn't always solve all the problems, like the shipping costs of shipping those back and forth became a bit of a problem. They tended to stack up. There was at least one instance where we accidentally shipped a rattlesnake back to the original supplier inside of a box. It was an unhappy supplier and an unhappy rattlesnake, by the way. So you got to watch out for those things.
True.
But luckily, everybody, no one was hurt, and so everybody had a sense of humor about it, except for the person who decided that we had illegally exported a Western diamond back to the wrong area of the country.
And probably, I'm guessing, the rattlesnake itself. But
rattlesnake itself, I think, ended up happy and in a zoo where it got fed, nice fat mice all the time. But
yeah, I'm sure that's what happened.
Actually, that is what happened, to be honest.
Really?
That's exactly what happened to it. Yeah.
It's a happy story for the rattlesnake.
A happy story. So we'll end today's episode of Power Players on a happy ending for a Western Diamondback that resulted from reuse, reduce, reuse, recycle sort of focus. So listen, final thoughts to you.
Our industry has a lot of work to do on better understanding full life cycle costs, on better understanding full life cycle technology and activity. Like there's a lot of work to do, because we have been so focused on everything that comes at the beginning of an installation. We really haven't yet done a great job of understanding the full impact of what we are doing and how to make sure that we're treading as lightly as possible on this earth. Within that, there's a lot of challenge and there is a lot of opportunity. And so I hope that with your megaphone of this podcast and your connections and your impact on this industry, Mike, we'll join together and try to shout that message across the time and the divide to make sure that everybody is thinking about this stuff. And the more we beat this drum, the more we talk about it at conferences, the more we talk about it during development cycles, the better we're going to get at it. Yeah. It's just like any new skill, any new approach we have to take. You start out, you fumble around, you get some data, it gets better. And we're going to get there as an industry. I absolutely believe that we will. But, this is part of our role right now, is to try to shout that message and get it a little bit more airtime in a few more conference rooms sooner than later.
Well, on that note, thank you so much for your expertise and your time today, Amanda. As always, it is a distinct pleasure to talk to you and to listen to the things that you have to say. You've been a thinker and a leader in this industry for 18 years, and you are far from saying I'm almost done. If anything, you're just accelerating. And so I have great respect and appreciation for everything you've done and for your willingness to spend time here with us today. And as I have said for the other folks, you are indeed a power player in the renewable industry. Thank you very much.
Well, thank you, Mike. It's my pleasure.
Find summary thoughts on this topic and more insights into operating your clean energy assets at origisservices.com. Thank you for listening to this episode of Power Players by Origis, critical thinking to deliver the clean energy promise.